Today, we're going to talk about power supplies. Can you hear me?
Well, I just started recording, so if you just want to just say your topic and then
Get it on there so they can get it. Are you ask them
Can
if
you
they're
hear?
listening out there? Can they hear us?
Okay, we're going to talk about portable power sources for doing portable stations, either camping or remote operations for doing special events, things like that. Okay, so part of the thing is that I started looking at it myself. And so I came across a bunch of terminology that I had to kind of look up again. And there's some considerations. So we kind of thought it'd be neat just to talk about it a little bit. Not the expert, but if you guys have something to interject, please do. Or if you got some experience you want to share about it, just let me know. Just shout it out. Okay. So starting with that, let's go to the first slide. Okay. So help me remember what we're talking about.
Here's a sheet. There's a cheat sheet for you.
Oh, my cheat sheet. Okay. Okay. So some of the things that we want to talk about, you want to think about if you're picking a portable power source, is it doesn't have to be dedicated for just one thing. You probably want to use it for other things like stuff at the house, or maybe doing sometimes supporting a campsite. Or sometimes you want to go just for an afternoon, sometimes for a weekend. So that's one of the things you want to consider when you're looking to buy something for portable powers. How much you really want to use it? How long are you going to use it? If you want to use it for multiple things, that's okay. You probably would take into account the longest you're going to use it for. That also means that it's more expensive, though. Okay. Another thing, this is just a list of the topics that we're going to go over. One of them's deratings. Is thinking about temperature, where you're going to be operating, how much power output you're going to have, and how often, it's called duty cycle, how often you transmit versus how much you receive, because you definitely use a lot more power transmitting than receiving. And then there's a little thing in here called upratings. It's like, figure out how much power you need for your radio station. Maybe you want something else on the side, like a fan or some other stuff. So you kind of think about what other kind of things you want to power at the same time and include that in your thought. Another thing you want to think about is how portable your portable power supply is, right? Is it going to be something that you can carry? If you're going to go backpacking, you don't want to get a gas generator, probably, right? So you want to take that into account and think about what you're doing for your portable power station. And then we're going to talk about some of the terminology that I ran into looking at stations, and then a couple examples of figuring out just roughly what you might need. Okay. Anybody got any questions yet? We haven't talked about anything. Okay, so all these things is kind of like juggling your checkbook. Okay, because we need power for some things, and sometimes we don't need it. So it's kind of a compromise, what you're going to use for it. I put some definitions up here since we talk about it. You got DC power. What we usually talk about it in volts and amps and watts. You hear, I'll throw watts around a whole lot, right? That's more or less your volts times your amps. And AC power, we'll kind of talk about it watts, but you'll see it in volt amps too, because it doesn't take the volt amps, takes into account the power factor, which is like inductive loads like motors and stuff. The other thing we'll talk about is energy. Come on.
Yay, joules.
Dog, yeah. Joules. Energy is power times time. Okay. Joule is a watt second. And a lot of times when we're thinking about longer term stuff, they're in watt hours. And sometimes you may see them in amp hours. hours too, if you're talking about batteries. And the reason is because batteries are a fixed voltage. So a lot of times I was talking about the amps, don't worry about the volts, but you can't change it. Okay, and then this is Regis's favorite term, joules. I think Back to the Future one too many times.
George once too many times.
Okay, next slide. Okay, one of the things I wanted to mention about thermal D rate. Not to calculate anything, but if you're going to be in a place like it's hot outside all the time, you want to make sure that you think about having a little bit more power capability or capacity for your devices. For example, if it's 100 degrees outside, the equipment's generally sized so that the receiver or electronics can get up to like 130, 140 degrees C before they start really restricting their output. So if you're going to be operating in a very hot climate, you want to make sure to have fans and stuff to keep the power output as is, because power output usually ends up turning into heat. Okay. Oh, look, I put numbers on there.
Right.
Hey, look at that. I put them in centigrade because that's what you see in the spec sheets, 50C and 60C. So usually for the operating stuff, this is that they're rated for their max temperatures at those. And if you're at 100 degrees outside, you're getting pretty close to your operating temperatures. And if you leave something sitting in the sun too, it heats it up. So you want to think about that whenever you're planning your power source. Leave some extra for heating if you're working outside and hot. Okay. The other thing too is if you run your equipment near the rated maximums, it burn them out. Usually you're operating when you size things, you're generally sizing them at 80% of their useful capacity because they'll last longer. If you're in current, this is the way we used to size stuff too. If you run at 70% current, I squared R. So if you square 70, half power. So that's you get half your heat dissipation. You run at 70% current. So a lot of times, if you're calculating stuff up, bump it, put fudge factors in, making sure you got room. That way you'll enjoy it better. And then I noticed too, I put a little note on here. If it's winter outside, sometimes these things get too cold. So you have to keep an eye on the specs of your power source to make sure it's warm enough to even run or get it warmed up. Okay. What do you guys think so far?
So leave yourself some headroom.
Yes. Fudge factors. Okay. Any more questions? Next slide. Thank you so much. You're awesome. I have a little example here on duty cycle and a little picture when we're talking duty cycle. And the duty cycle, like says 50% duty cycle, means that it's on half the time and off half the time. At 75% duty cycles, it's on 3/4 of the time and off quarter time. So what you end up doing is taking an average of that. Okay. Same like 25% duty cycle, only running a quarter of the time. So you can use that as a way to really figure out what you're really using as far as your power. Yes, sir.
Do they have little meters that could tell you that so you wouldn't have to use a calculator?
No. You might have to figure it out yourself. And I put a little example here. The one thing that's a little bit of a gotcha is if I was operating my radio and I says, I don't talk a whole lot. So I'm more like the 25% duty cycle where I listen three times more than I talk. One of the things it doesn't take into account is that it consumes power even when you're not talking. So that's one of the things you throw into. That's why I put a little equation here. is that you have to account for the watts. There's watts here in standby, and then I do the duty cycle stuff, and then add them together. Okay, so that's how you figure out how much power you're really consuming, and you're only doing the calculation to try and get you a thumb's viewpoint. It's rule of thumb, figure out what you need, approximate. None of this is going to be exact. Okay, any questions on that? You're awesome. Have you done this before?
Mhm.
Okay, so another thing is we talk about digi modes, right? If you're out doing digi modes, generally you're turning your power down by half anyway, and you can use that if you're going camping someplace and you decide, well, I'm going to go backpacking and I'm only going to run digital. I'm not going to be talking on a mic or anything. You say, okay, I'm going to turn the power down halfway. How many batteries I need to take with me? Well, if you're running half power, you can take half batteries with you. Instead of taking two, you can take one. And that's the thought behind that. But this is just thinking about what you're doing may save you some time and energy packing what you need. Okay, and I wasn't going to talk about all the calculation part, but it's in the slide there if you want. Okay, here now I'm getting to the examples, and I'll explain them a little bit. Okay, so my radio that I had here last time, it consumes 20.5 amps when it's transmitting and 1.5 amps on standby. Okay. The other thing that you had to think about was a lot of times I'm not feeding it straight from the DC battery. If you're feeding it straight from the battery, that's probably, it's pretty close to spec, right? But I was feeding mine from a switching power supply, and I was too lazy to unplug it, so I just plugged that in. Well, that switching power supply is not efficient either. So it loses, it's like running 80% efficiency. So I'm having 25% losses in that. It's got a little fan and it gives off heat, right? So rather than consuming like 280 amps, I'm actually consuming 330. So that's kind of another thing to think about. Yeah, thank you.
You can give it to him.
If you want the,
No,
Later.
I'm not
Oh.
licensed for lasers. That's dangerous.
Can the guys on the Zoom hear you?
yes, I've asked them. They said yes.
Okay, that's fine. I just want to make sure.
Okay, so that was one reason why you have to think about some of the other inefficiencies in there. I have some watts losses that I really didn't think about before, right? And then it's just I threw a monitor and a PC on there too. Oh, well, crap! I'm running out of power in my battery and my inverter. I decided, oh, at nighttime too, I'm going to plug in 300 watts of floodlights. There you go. Yeah.
Use LEDs over there.
Well, that was my plan anyway, right? So I want to see, what does that do to me in cost and everything? Not only, and this is a famous one, it's hot outside. So I brought a box fan with me. I plugged that into it too. And so, okay, this doesn't take much. Yeah, that box fan took 90 watts. So it was about a third of the power of the radio. Then, yeah, I wanted some extra power there too to charge batteries of the phones, and maybe a screwdriver battery and stuff. So I threw another 50 watts. So I was like, okay, for powering this station like that, in the daytime, I need 550 watts. At nighttime, I need 850. So when I'm going shopping for my load bank or my generator, do I really want those floodlights? Maybe I'll just get a LED flashlight or something. And then I made a note here about if you start running QRP and start doing backpacking and summit on the air and stuff like that, you're going down the other pipeline. You're trying to get small as you can, and those get really small. Just like this battery here. I'll show you this battery. This is a battery from a RC aircraft. Now it's the same stuff that they have in the QRP radius. Actually, this one's probably pretty huge. This is a 2-amp battery. Because I built a really big airplane. And so I put a big electric engine in it. So I bought a big battery. This is 11 volts, 2.2 amps. Okay. Yeah, that's how ooh. This is one of my bigger batteries for doing airplanes and drones and stuff like that. But it's the same battery. You can take these camping too, power inverters. But when you go QRP, that's kind of what you're talking about. You start to even get probably about a quarter this size.
Like a lipo.
Yeah, this one's a lipo. Then if you start talking lipo batteries, then we have to have another meeting for all the different ratings that you see on here.
You said it was a flux capacitor.
It do. That would be another meeting. So we can have
All the way to the
we have program meetings for the next year. Okay. So then I was evaluating another guy's power needs, and this was for Regis. He had a mega party station set up. He wanted more than just his radio and the lights. He had a refrigerator. So he had a cooler sitting there, one of those LTA module refrigerators that run off 12 volts. So we kind of says, I wonder how much that consumes. Actually, it's not too bad. It consumed 54 watts. But then Regis, decides for his party station too, he needs a solder pen because he likes to solder. He's not really soldering anything. He just likes to melt it. Makes him feel better. And then he had a 5,000 BTU air conditioner. Wow.
I'm going camping with him.
See.
So that's 500 watts, and it's got a motor and it says inrush current. So you have to watch for that too.
What is inrush current?
Inrush is when you turn a motor on AC. It doesn't have the magnetic flux built up yet. So what happens when you first power it? Not only you get the current that you need for torque and spin, you have to get the magnets magnetized. So that takes another 50% current. Sometimes it depends on the device too. Some of them take up 300% current. That's when you see the lights dim when the air conditioner pops on.
Okay.
That's part of the
called
reason why,
inrush. I
'cause it
just
just
never
gets a nasty.
Just never heard it. Maybe very common, but I
Stick around with me, buddy.
have. Okay, brother.
Okay, so you're building a pretty massive party station here. And then you have this 20-foot inflatable blow-up screen, right? That takes up 360 watts, and your LCD projector, so you can look up the QRZ at 20 feet. That's another 250 watts. Ray just needs a couple thousand watts for his.
Yeah, but there's usually 15 people in my party.
Yeah, but your parties are fun. So that's a couple different situations.
I have a question.
Please ask, throw your question out.
With all this other stuff going on, when is Regis going to have time to operate his radio?
Oh, that's not important.
Regis,
It's the process. Not the end
Regis is a
result.
station manager. He schedules the operators.
Oh, I see how this works. Ah,
I'm getting my feet wet. Wait.
And the other thing is, this is kind of peak part because he doesn't always run his projector. He doesn't do that during the day. So, you can juggle that kind of stuff. Okay, so that's kind of a couple different examples. You kind of run through what kind of loads you want. and what kind of things you want to supply off, what you're going to do for your portable power supply. I don't know why I'm hanging on to this. Yes, I do. I was going to show, yeah, there is a reason I was hanging on to this. Got a plug. I was going to plug it in. This runs off. Got an AC plug. That's a 100-watt inverter. That's how bigger it is. I just plug it in, put it into battery. We'll turn on the lamp. There, you got Halloween decorations now. Power from batteries. Ooh.
Ah.
All right. Okay, so now if we get down the road for QRP rigs, it's a little bit different because a lot of your power, if you have like a PC, your PC is probably drawing more power than anything else, but it's got its own battery. So I kind of went through a little exercise here off the spec. Last time we had I forget who it was that had that little QRP radio. Steve Jinghu X6100. I didn't write down who it was. I wrote the radio name down, right, and looked it up. And it had a 3,000 milliamp hour battery at 12 volts. That battery is not much bigger than this one as far as capacity goes. And so if you are running it, just receiving, it consumes 330 milliamps. And if you're transmitting, it's 3 amps. So if he's just sitting there with the 3,000 milliamp hour battery running at 330 milliamps just listening, it's going to take, it'll sit for 9 hours just listening.
Just wait, for cum, what does that stand for?
The who?
CUN,
Where?
The
third bullet down.
yeah, or CUN high
I've never-
resolution color screen.
I'm not familiar with that term. CUN, four dash CUN.
Oh, yeah.
So you don't know.
That's color units per 9 inches.
Well, thank you.
I think that's a typo.
Oh,
I'm
Okay,
not sure what that is.
So you could have left that out and just said high resolution color screen.
Yeah, I was cutting and
He's
pasting
copying.
from
Yeah.
Right, okay.
cutting and pasting. I might have
Yeah, it might have been
fat fingered something.
supposed to be 4K
it might not have been
then. 4K.
it might have been a translation error. That you were pasting that from
that may
the
be on the internet. If you
Chinese
want to
specs.
Check that out. right
Okay,
now.
well, anyway.
No.
Yeah.
Keep going.
Okay,
It's
okay. So this is just kind of a rough idea to get how long it would last if you're not even doing anything. And if you're transmitting a 50% duty cycle, you can get a couple hours out of the battery running URP. So if you even cut your power down even further, it gives you an idea just how much battery you need. Okay, so you don't need a whole lot of power either for batteries. So if you're camping, you probably want to bring a couple batteries, so you have to go recharge them. It's probably not packing solar panel or generator or anything. Okay, thank you. So I kind of thought about it. So whenever we've gone to visit people that have portable power stations, what kind of different power sources have they used? I've seen the big generator sitting out there, like Dave's trailer, right? You got a generator feeding that because he's got air conditioner. I'm not sure what all's running in there. Then there's these other type of generators that you've seen out that they're called inverter generators. And they have a whole different construction built onto them. These other ones here, they run on gas and they're direct coupled to a AC generator. They've got a governor in them. They regulate the speed, keep your frequency correct and the volts and everything. This one here is totally a little bit different. It's a little, the way that it generates the power is more like a car alternator. And it's got an inverter in it. So there's some things about the inverters we want to learn about. And this is a real popular thing, and this is a power station. And I've seen some of them run gas, they're electric, they run solar. I've even brought one. That's what this is right here. We can talk about that a little bit. I think you have one, but they're kind of neat because they'll take in a whole bunch of different kind of power sources. And then it looks like a lunchbox is full of batteries, full of LiPo batteries. And then we have the fabulous deep cycle battery you can use, right? And then you can use that direct to your radio, and then you run it off a DC, all your other DC devices. And then there's all this hodgepodge of stuff you can put around it. You put the solar panel with the charger, hook it to the battery, and then you can just get a straight 12-volt inverter and run it. And this power station is all that stuff combined. But this, of course, if you build it together, it is can be a little bit. It can be cheaper, but you can size each component to what you want it to be. Okay. Any questions on that? Have you seen all this stuff before? And I put the big 57 varieties on there because it's like, you start trying to look up anything, there's like combinations of combinations between the different styles and types of things you can do with them. You are fast. Okay, so about the open chassis generators, I kind of had gone through and did a little bit of picking on about looking into what an open chassis generator can do. Neat thing about them, they can run on gas, propane, natural gas, tri-fuel, dual fuel. You can get whatever you want as far as fuel. They're pretty inexpensive comparatively, but at the same time, they're kind of heavy, a little bit loud. If you're in a trailer, it's not going to bother you nearly as much as if you're just sitting outside next to it. And generally, they have a pretty high power to them. The thing you want to think about when you're getting them is the different kind of run times. These things will run pretty well. They usually have a pretty good gas tank. If I remember too, from the last presentation that we talked about, there's some grounding when you're using a generator. These ones here are heavy enough. They got the ground to the frame, and they consider it touching the ground as good enough ground your equipment with. The other ones, I haven't figured out what they think the ground is. These ones generally have more outlets. I'm blocking. Okay, and so this is the regulation of the frequency and the voltage is there's a lot of mechanical to it. Got the governor in it, but it's old technology, but it's proven. It's been around for a long time. One of the points is that I didn't realize was I figured that this would be the most sinusoidal output that you could get, kind of like you get off the grid, plug in an outlet. But no, actually, some of them you have to get a better one to even have 6% distortion. It says some of the crappy ones have like 15% distortion to them. They're not really meant to power a hospital for emergency power. They're a little bit loosey-goosey. But it depends which one you're getting. Whether you're getting a better one that's got better voltage regulators in it, whatever. But whenever you're looking up, you got to pay attention to all those specs. I kind of assumed you just get a generator all the same, but there's a lot of difference in them. Okay. Oh man, you're like thinking just right there. So this is an inverter generator, and this is what's really a lot different than the other generator. You've got this little engine turning this alternator, this 3-phase. Boy, that's pretty cool. The big generators are a split phase usually, a split single phase. This one's got a 3-phase alternator on it, and it goes through a full wave rectifier. 3-phase. So your DC voltage has a lot less ripple on it already because of the 3-phase. And then it's got an H bridge on it. You guys want an H bridge? Okay. It's called an H bridge because the output comes in the middle, and then there's 2 legs here. This is DC and this is DC, and it looks like an H. Okay, so whenever you want to have the power flow through, like fire this one, and it comes shooting through here, come back through this way, and then this one fires. So these 2 fires a pair, these 2 kind of fires a pair, and you can sit there and chop at it. And it'll make your AC waveform. And it does a lot of things because it can be a lot more fuel efficient because this generator RPM is a lot lower. That other generator with the open chassis are running constant speed all the time. These things will slow down because they don't need the power. It'll throttle back the engine, throttle back the fuel that you're using. So if it's under light load, it spins less. Pretty cool. And then it's got these filters in it. This is how they did the sinusoidal type of output. Filter it a little bit. Let's see. It just says, and then it says you get the Yamahas and Hondas, they're a lot more expensive. I think partly because they're very popular, and they're pretty good. Okay, that's interesting, isn't it? Oh, and this is the magic slide. Last time we had one magic slide is bordered in color.
Just going back on if it isn't or Yamaha, and maybe it's one that costs a little less, quite the quality. What component is like? I mean, I got one at warehouse place, and worked great except it messed with radio RAM. So I had to send it back. But was it filtering?
I'm so happy you asked me that question because that's what this slide's about. Where'd it go? There it is. That's Daryl. He's like getting ahead of me already. Okay, how am I doing on time?
You got 20 more minutes.
Okay, I'll go faster. No, I'm actually we're pretty good shape. So we're talking about a sine wave. This is what the sine wave looks like. It's very clean, 60 hertz, really nice. This is so beautiful and smooth. If you have like a really, really old inverter, like I had bought an inverter like 40 years ago, put in the car to run the TV and VCR. That's because I want to have the TV and VCR running in my car for the kids. Keep it quiet. All it did was put out a square wave, and it put it through a transformer. It was pretty big. They don't do that much anymore because there's a lot of harmonics with a lot of heat. Not very efficient. But if you see something that says PWM output, and I didn't see Pat, but Pat had one of these things, and he had a battery connection that he would plug in, and all of a sudden his radio started picking up all kinds of noise. That was because it had one of these outputs. This is a PWM, and this is a pulse width modulated sinusoidal output, but it's not really a sinusoid. It kind of mimics it if you got a heavy load on it. It has really thin slices of the DC voltage on the low and the low side, and as you go up in your AC voltage, the chops get wider. And these chops happen really fast. Like big power stuff is like 2 kilohertz to 16 kilohertz, and then you can get to a lot higher than that. Get up to to 300 kilohertz for some switching power supplies. And so that's where they start, these switches are heat. They generate a lot of heat. And this is where you get your noise from. So if you've got that inverter that we've got, it may have had a PWM power output like that, where it was putting out noise. I've also seen on these things, they have a thing called a modified sine wave output. And that maybe is what was causing you. This box here, I'll bring it close because I know that you're old and you can't see. It says pure sine wave output. Okay, some of them don't say pure sine wave, they say adaptive sine wave. And the adaptive sine wave for you see? Okay. Adaptive sine wave is kind of, actually these are called two-step inverters. They do better on the harmonics, but they're not the same as that, as a sinusoid, right? And so I noticed one of those slides, maybe it wasn't that previous one, but they'll say a modified sine wave, and that's where you get noise too, because you get this big chunk right here. You get a step in there, and you need harmonics to make that. There's the other way around too. If you have it, it creates harmonics. Okay.
Do you
Question.
avoid those kind of power supplies that have them modified, or are they okay?
You can. It's what you buy. That's why you want to look at the specs of what you're buying. Now, the thing is too, that a lot of equipment will run with this. Actually, another slide, there's a big long list of things that won't run with this. They said, but if you got like a breathing machine or like a heart defibrillator strapped to you, don't get one of these.
When you buy it, the specs will tell you what to run on it, what it won't.
Well, it says it on the box, yeah, what type of output it is.
And as general rule of thumb, cost is going to guide you. So that cheaper generator at the Harbor Freight, that's it says it's a 2000.
Yeah, the Predator.
Right,
Predator.
but it's only $400. And then you look at the Honda, which is also 2000 watts,
Yeah,
but it's $1,200. So that Honda is probably going to be a pure sine wave versus that $400 one might be a modified sine wave. But if you look at the book or look at the specs, it's going to tell you. So I've done the same thing that Tom's done. I bought the cheaper generator at Harbor Freight, found that it put out a lot of noise, and when the radio would operate, but you could see that it was creating a lot of noise. And then I spent more money and bought a Honda generator, perfectly quiet, no noise whatsoever. So what I've done with my 7300, I plug it into the cheaper generator, look at the LCD screen, and I see all these little spikes where all the noise is. Turn the radio off, plug it into the Honda, start the Honda, turn the radio back on. There's no little spikies. So that's a non-technical term. It's like little spikies versus no little spikies.
Pay for it.
Right, exactly. So I turned around and sold the cheaper generator to someone who didn't care. And anyway.
Actually, Harbor Freight took it back in 2 weeks. Said drain the oil out of it, take it back, and I also got a warranty on it. Give me every penny back.
cool.
So, but the moral of the story is you get what you pay for. So that's why the Honda generators cost more money, but they're better quality.
Okay, next slide, please.
Next slide. Okay,
Yeah.
I can handle that.
Okay, this is the power station. Just kind of like what's sitting over there. This one's kind of neat. This is a jackery. This is what I spent a lot of time on the Harbor Freight site because it's the first place everybody likes to go. since Sears is gone. Right. But anyway, so the kind of neat thing about these is pointed out in the slide here is that they're quiet, they're really easy to use. They don't really have any moving parts. This one here, mine over there has 2 cords, has an AC cord. I can plug it into the wall. It can actually run as a UPS. If I want it to. You can program it. There's a input for the solar panel. As I actually showed Daryl a picture, I was like shocked. I had a 100-watt solar panel plugged it in there Thursday morning, and it was kind of hazy. There's a watt meter on there that tells you what the solar cell input was coming in, and it was sitting at 80 watts, and I was shocked. That's pretty cool. But the neat thing is if you run off something like that, you can charge while you're operating.
How much does it cost?
That was $200. But I wasn't happy with the wattage, but I was happy with the price. So I figured I'd turn the power down a little bit if I needed to operate sometime. But the other way, if it's the daytime, I'll probably have a solar panel hooked up to it anyway. Okay, and then there's a bunch of stuff about clean energy, all that groups and stuff. But it's like the other thing is it can only generate when the power through the solar cell when it's sunny outside, right? Nighttime, it's not going to be so good. If you're running field day and you want to run off onto that, that's fine in the day. But nighttime, it'll probably fail on you.
I just want to comment, I've got one of these, but it's a smaller one, and you really can't run the smaller ones. You have to look at the size of them. You're going to run 100 watts. You gotta make sure it's big enough,
Yes,
because the smaller ones aren't big enough.
yes. This one over here, it actually has 2 ratings. It's 300 watt and 600 watt. So what you can do is if you have something that has inrush current, you have like a 2-to-1 leeway in there, because it'll take 600 watts probably for 2-3 seconds, and then you're running at 300 watts max. But you'll see those ratings on these things too, and there's a bunch of different ones. Okay, there's a big picture just showing. I liked it. It showed all the different ways that you can charge this thing up, and also different ways you can discharge it. Hardwired, everything you can think of. But then it's just, if you start getting 1,000 watts, 2,000 watts, it starts costing you some money. Okay. Am I running out of time?
Got 10 minutes.
Okay. Let's keep going. I'll crank it. We'll get it done because we're almost there. Then the last little bit is just talking about deep cycle batteries, right? And you can go life batteries, you can get these LiPo batteries. There's some other batteries that are new that are just out. If you want to stick with the old deep cycle one, those you can get those and they'll last you all day, right? Depending how big of one you got. Or you can stick a solar charger on it too separately. Stick inverters on it, do your own thing, kind of like that light's doing. Okay. All right. Now, the one thing you'll hear about different inverters for the solar panels. There's one here that says PWM. I remember if you saw the station, my Go kit had a little box on it for doing solar charging. That was a PWM one. This one's called MPPT. It has for max power point tracking. Right? So what is solar panels are kind of flaky. Don't put out so much current, and then if you load them down too much, they just kind of die. So there's also, as you put more sun on them, voltage comes up. So there's a point, this is called the max power point. So what they do is the chargers will sit there and dingle around those points and try and keep that at a maximum. So it's constant, it's like a regulator, trying to figure out what the maximum voltage is. Keep it there so that you have the best charging capability.
And why does it fall off?
Why? Because that's what they do.
Yeah, it's just a characteristic of the cells. That if you put them under too much of a load, then they give up. They
Forever or until you stop?
You take the load off it.
take a look, yeah.
Actually, they've got diodes built in them too for that. If you had a bank of 100 of them and the cloud came over, cover two, it doesn't stop producing. It bypasses the two that are in the shade. Yeah, there's all kinds of crazy stuff. And it also depends too on the angle, how much sun you got. You get real technical into that. And then I had a little drawing here. This is the PWM charge controller, and they're really simple. Here's a picture of the battery. Here's the solar cell. There's a couple diodes, kind of like fires it, connects it right to the battery. So it sits there and pulses it. So these PWM ones are a little noisy. These MPPT ones are a little more subtle, but they're not nearly as noisy. Okay. So those are a bunch of the terms that we had. Let's go to the next slide. Oh, okay. Some other stuff that I kind of found that I thought was nifty. Open frame gas chainers at runtime up to 9.5 hours at 50% load. Well, this pure sine wave guy, he's super quiet, and he's even got longer runtime. He'll run 12 hours at 25%. I don't know if you guys caught that. This one's at 50% load. This one's at 25.
That one probably holds 3/4 of a gallon and the other one like 3 or 4.
Yeah. And then I had, this is interesting. I threw a bunch of interesting crap in here. This is 65 dBA noise and weighs 60 pounds. This one's 50 pounds at 58. And this dBA noise is, the A stands for the weighted curve that they put on them, because your ears hear voice frequencies much better than at the ends. So if it's putting, it kind of takes the noise output and it fits it to that curve, because your perception of the noise is different. Okay, I thought that was nifty. And then this is kind of like the audio curve, just to give you an idea. If somebody says what dBs are, you can look it up. And the quiet generator was like a 60 chassis, like 65. And I was like, holy smoke. It doesn't, that number doesn't look very big, but it actually is a lot different. As you get down here, 3 dBs half power. You can kind of think of it that way. So those dBs make a lot of difference when you're picking that stuff out. Okay. You switch on me already?
Mhm.
Oh, you're good. Okay. So what was I up here for? Oh, to dig into the spec. Yeah, the noise. This was a mice fart. Weighs 21 pounds. So compared to the other two, it's a lot lighter, right? It doesn't make any noise, but it's not going to run forever, right? It's like 2,000 watt. This is what got me too. It says 2,000 watt peak output. Yay. Yeah, but it's only 1,000 watt continuous. So it's kind of the same ratio. You can hit it. The slow time, the short time overload is built in, but it's not very long. And then it's really the numbers that's really important. Is 880 watt hours. So how long can Regis run his party station on that? Probably not long enough to watch a whole movie. Okay, this got charge times. I just put some examples over here. You get 5, this would run 5 hours, running at 30%, the big rig. You run digital, run 7. Okay, now this is another little thing that I hopped over to the batteries because I found some interesting things on the battery. When you're looking at the batteries for deep cycle, they've got cranking amps just like a regular car battery, old crank amps, and they have this thing called reserve capacity. What the crap is that? And really what it amounts to is how long it'll run at 25 amps. So, and I figured out that reserve capacity 140 means it'll run 700 watt hours.
3 minutes.
Okay,
A lot of radios won't run on 10.5 volts either.
what's that?
A lot of radios won't run at 10.5 volts, so you really only get 50% of the amp hour capacity of the battery. Where you risk damaging it, where your radio shuts off.
Yeah, that's a good point. I should have put that in. You should have reviewed this for me. Okay, so I just put some notes here. If I want to run deep cycle battery off it, I can put an inverter off it, put solar panels. They still do the same job. This is probably a little bit less, probably a lot less than one of these super battery stations. But you have to put it together and keep the pieces maintenance and figure out how to gather them all up. Okay. Oh, time limit. Yay. Okay, so we can sit here and talk all night about batteries and stuff and everything like that. And the heat sinks and how they work. Yeah, and I figured this is good enough for today. Was there enough information for today? You guys?
Yep.
Plenty of information.